Callan Bentley, welcome back for another Smart Figure. After watching this video, you should have a better sense of the vastness of geologic time. So one of the things that you'll learn over the course of your physical geology class is that geologic time is really vast. And it's been divided up into a series of chunks of time that have different lengths and have some pretty wacky names. So you can see some of those names here, including the Precambrian, the Archean, the Proterozoic, and the Phanerozoic. The Archean and the Proterozoic and the Phanerozoic are all the largest slice of geologic time, what's referred to as an eon. And what we've done here is we've blown up the Phanerozoic into the geologic time scale that you see in the middle of the image. So there's a lot more detail in the Phanerozoic because that's when we have multicellular animal fossils. So for instance, trilobites are found from the Cambrian on up to the Permian. And we find things like fish fossils from the Devonian all the way up until the present day. But all these different divisions are based on changes in the fossil record. And after the fossil sequence was established and names like Cambrian, Ordovician, Silurian, Devonian were laid down, we discovered that we can actually figure out approximately how old in absolute terms these different eras, periods, and epochs are. And that basically comes from radioactivity. So the steady breakdown of radioactive isotopes has allowed us to date minerals, which allows us to date rocks, and that has allowed us to assign dates in terms of number of millions of years before present for the beginning and the end of these different periods. So for instance, the Jurassic period, which is one you've probably heard of before, started just under 200 million years ago and ended about 145.5 million years ago. Now, the vastness of geologic time is a hard thing for a person to wrap their head around, so an analogy may be useful. If you condensed all of Earth history into a single calendar year, you would see that most of Earth history is that Precambrian portion of geologic time, where essentially there's not a whole lot of fossil record. So we have the origin of the Earth on January 1st at midnight. February 28th is the age of the oldest known rocks. There were probably rocks that formed between January and February, but they were all likely destroyed by the processes of the rock cycle. We think that life probably began in late March. Then April, May, June, July, August, September, they all roll around, and there's not a whole lot of changes to the living organisms on Earth. However, the biggest punctuation mark in the geologic record is in mid-November, and that's the beginning of the Phanerozoic eon. That's the one where we have lots and lots of animal fossils. By late November, we have plants and animals moving out of the sea and onto the land, and then most of the action takes place in the final month of the year, which is December. So if you look at December, you'll see that from December 15th through the 26th or so is the Mesozoic era of geologic time, and that's when dinosaurs dominate on the surface of the Earth. Our own history doesn't show up until the very last day of the year, December 31st. So if we zoom in on December 31st and look at the afternoon on that day, basically what we're looking at is that the oldest anatomically modern human fossils show up around 11 minutes till midnight. At about 1 minute and 15 seconds until midnight, the last of the Ice Age glaciers retreat. And then in the final minute of the day, basically we're looking at the rise and fall of various civilizations, Columbus arriving in the New World, and then, basically now. So in this perspective, where all of human history is occurring in 11 minutes out of an entire year, you get a real sense of how incredibly deep geologic time is. Another analogy that I find useful is the Washington Monument. This is an obelisk on the National Mall in Washington, D.C. You can think of the height of the Washington Monument as being proportional to the length of geologic time. So the base of the monument would be the condensation of the solar system, the nebular theory for the formation of the Earth, and then basically the whole Precambrian taking place up until the little pyramid up towards the top, where we see the first fossils of animal bodies, and then things like dinosaurs would occur up towards the very tippy top, and then finally all of human history would be the thickness of a sheet of paper draped on top of the Washington Monument. For review, let's try a little game. Let's see if you can take the geologic time scale as it's presented over here on the left and then rearrange that geologic time scale so it matches the proportions of geologic time. Hopefully what you said is something like this, where everything from the Cambrian up to the Quaternary all gets condensed down into that tiny little bit right there, equivalent to the top of the Washington Monument, and the Precambrian gets blown up to its true proportions, which is most of geologic time, basically everything before mid-November. Thank you for your attention. This has been another Smart Figure.